Alrighty, what's up, guys? So, I am excited to be able to give you the newest version of Photon 3D. Um, if you don't know, Photon is a sprite stacking engine. It uses actual 3D techniques, but it allows you to create models, 3D models, using a bunch of little sub images like this, right? So this is like a little block. There's like 32 images. So let me show you, and we're going to do a quick little walkthrough on how to set up and just show off some of the features of this engine and how it works. So let me just play this real quick. And so, boom. We got a little scene here. We got a ton of little blocks. Got a little guy that moves around, faces the camera at all times. We got all kinds of different blocks here, just doing random little wiggles and whatnot, different Z heights and everything. And it is, I tried to make it even easier than the original Photon was to set up. So, yeah, pretty much. I'll just show you how to kind of set up this little scene here real quick. So, let me get rid of all of this because we're just going to start from scratch. I'm going to keep the sprites. Keep the sprites there. If my mouse will start working. Didn't mean to put that there. And let me go into this uniform control and get rid of this because I'll have to show you how that works too. Boom. Alrighty. So to start off, to make a project, the newest Photon is crazy easy. There's like one script that you need to call at the beginning of your game, and if you look under systems, it's right here. It's called Photon Start, right? Just this, and it's got a couple optional parameters. That's all you need to call at the beginning of your game to start. Then we've got some pre-made nodes, a render pipeline, and a camera. You can use these. This is by default. This is the default. There's a default shader and the default pipeline. But let's say you wanted to create your own with your own like post-processing effects or whatever. You could just throw them in here. You could just create a new object, parent this object to it, and then the draw GUI. You know, do set some shaders to the screen or whatever you want to do. If you want to make a new one, you're more than welcome to. It is advised to basically parent these though. I mean, you can make your own camera. Everything's decoupled, so nothing relies on making sure you have these two. But you do have to have a render pipeline. That is one thing. Just because well, you don't have to. You can draw everything manually too with Photon if you really want to. You don't have to have this render pipeline, but it's for the like handling the buffers and everything like that. It's just I've tried to make it to where it's super easy, so you can just slap that on in there, or Photon Start will automatically create a render pipeline. But that's the necessary part really. If you don't want to call this script, you can just throw in a render pipeline into a room and it'll work fine too. So under user utilities, these are all the things you're going to really need to play with or use. We've got the toolkit, which has got a bunch of different functions, creating and setting and manipulating models. We got some sprite functions, so draw Sprite-3d, ext, and then we've got like some individual ones, Photon ones, and then we've got buffer functions. So I guess we'll just go in and we'll go ahead and just show off how easy it is just to go ahead and create a model. So first thing, I'm going to create a folder here, and we're going to call it objects. We'll create another folder, shaders, because I'm going to show you how easy it is to add shaders to static buffers. And then create another group, and we'll call it rooms. We'll just create a little room here. Just create a standard room, call it room test. And obviously, initially, this would be like an init room, room init. And in the creation code, I would put Photon start. And you only have to call it once. There's some parameters in here. We'll get to these in a little bit. There's a resolution and a fidelity parameter, but you don't have to set them. They're optional. Photon by default will give you the pixelated orthographic look. So you just call that at the beginning of your game. That's all you need to do. In whatever room, just the first room that you're in. Photon start. Then let's add a new background. We'll call this floor. set that there, and I'm just gonna set it above here. Really, the ordering doesn't matter, but regardless. So we'll just stretch that out, and let's go ahead and I'm just gonna add in the default camera, the one that comes with the engine here. Instances, we'll just add that camera right there, right in the center. And let's just create a little player so we can just kind of look around and everything like that. So under objects, create a new object. Call this ob player, and we'll give it our little player sprite here. We'll go ahead and throw that in the room as well. Boop. Alrighty. So just to move the player around, well, I'm also going to click show debug overlay, so that way you can see performance as we're doing this. So I got that. We'll go into step, and we'll just create some little inputs here, some little so we can move around. So H equals keyboard check ord D minus keyboard check ord A var V equals keyboard check ord S minus keyboard check ord W. Then we'll just say var moving is equal to point distance 0 0 H V, and I've got in the camera I've got an easy little variable. You can just say camera dot forward, and that's why I would suggest parenting that camera. If you want to create a new camera, you can create a perspective camera if you want or whatever, but I would suggest just parenting it so it's just easy. You can just always call camera and throughout your game, and you don't have to worry about it. It's basically like a class, if you will, instead of having to check that object camera exists or whatever. You can just do that, and if it's parented and it exists, otherwise you'll get an error. But anyway, so moving, we'll say if moving, if we are moving direction. Yeah, hold on. All right, I need to get rid of that. All right, that's not where that goes. Sorry. Direction is equal to point direction 0 0 HV plus camera. That's shader stuff. Plus camera dot forward. All right, yeah, sorry. I put that in the wrong spot. This is just to see, we'll need to do greater than 0.5. This is just to see if we're actually like pressing buttons and moving, and then we'll move in a direction that we're moving plus our forward vector of the camera. And then we'll just say speed equals lerp speed to moving times 2 by like 0.3. Then, so that's just some basic movement stuff. Pretty easy to set up. Then in the draw, we can just say draw Sprite-3d, sprite index, image index. Now I've got some variables down here, or I've got some parameters down. You got X, Y, Z, X rotation, Y rotation, Z rotation, X scale, Y scale, Z scale. And then we've got a facing camera. So this, if you set this to true, pretty much all of this except for the X, Y, and Z position, it doesn't matter. It will automatically face the camera and correct the scale and all that for you, so that way your sprite is just like basically a billboard. It's good for like particles and stuff, or in this case I'm going to use it for the player. So say X, Y, 0 is our Z, 0 0 0 1 1 1, and we'll set facing camera to true. Super simple and easy. All right, so we got that. Now we just need to go into our camera, double click the camera here. I'm going to turn that off. Double click the camera, and under variables you've got a bunch of little variables. So we can set the target. We'll just drag our player over to the target here. You can set the view width and height. I'm going to set it to 280 by 720 so we can see a little bit better, or 1280 by 720 so we can see it a little better. You got sensitivity, viewport, which is just if you wanted to set it to a different viewport here, you can do that. It's just by default set to 0. Interpolation is how quickly, like when you rotate the camera or pitch the camera, that's how fast it will interpolate that. And then speed is how fast it will chase the target, basically. So we got some there. Mouse lock, by default set off. You want to set that to true so that way you can look around. And then this is if you wanted to like invert the vertical or horizontal axis, So If you are a person that likes to move the mouse down to pitch the camera up, you might, by default, I think that's what I have it set to, but you can choose one of those, -1 or 1. And then we got pitch range. By default, set to 45. Um, this is basically from 45 degrees up half of 45 and down half of 45. So if you set this to 90, this will make it so that you can look all the way above the player and then all the way to the side of the player. But it's just optimal to keep it at 45. You can play around with that. But yeah, I think that's all we need to set up, and let's go ahead and run it and see if everything's working right. See how easy that was to set up, and look at that. Bam. Now I got the view set pretty big, but just move the player around, and look at that. Perfect. Easy. No, not difficult at all. Not difficult at all. So, what about? Forgot to add an escape there. Whoops. I'm gonna add that in real quick. So we'll go to key pressed, others, escape, game, end. Awesome. Okay. So now for adding models. There's a lot of different things you can do with models. So the first thing, we're just going to create the basic cube. So we'll just call this cube. Set it there. And in the create event, all you need to do is say Photon model create sprite index x y 0 0 0 0 1 1 1 not 0 0 1 1 1. All right. So this is just if you wanted to just create a model and just have it in there. I would suggest setting this to visible, because with this new system of Photon, the render pipeline will automatically draw these. So you no longer have to parent models or anything like that. All you have to do is just call this, and it'll create the model in the scene at these positions. So, and if you wanted to update the model, you could, there's a Photon model set where you just put in the model ID. So we might say, actually, let's just do that. So we'll say model equals, you don't have to call that if you just want to slap in a model real quick, but model equals Photon model create. We'll just create a, we'll just do that. Then the step event, we'll say x is plus equal to the cosine of current time divided by 250 divided by 2. Y is plus equal to sine current time divided by 250 divided by 2. And we'll say Photon model set model x, y, 0 are, for some reason, GameMaker's not wanting to pop it up yellow for some reason on my computer. I don't know why, but it's X, Y, Z, the rotations, and then the scales. So X rot, Y rot, Z rot, 1, 1, 1 for the scale. All right, that's all you need to call. And this will make our little cube here just rotate around in circles. Did I make it? All right, I made it not visible because we don't want to draw the actual just sprite, So let's just see. And if we look there, boom, it's just moving around in little circles right there. Super easy, super simple. So let's get rid of all this. One of my favorite features is, I guess another thing too is, all right, let's say, I guess I should cover this first. So let's say, we have that cube there, and we'll just create the cube, right? So we've got, make sure everything's working right. Use Photon model create, bam, we got the cube there, right? Well, let's just say we want to destroy our instance, right? Instance destroy. So we've created a model, and now we're destroying the object. If we look in here, the model's still there. That's because you've created a new model in the actual rendering pipeline, but it's not attached to this object, right? Because this object isn't drawing the model, the engine is drawing the model. So you always need to make sure if you're going to have, if you have the engine automatically drawing for you, instead of using, there's a function I've got in here where you can say Photon model draw override, and then you can draw the model yourself. But if you don't use that, you just want to create the model real quick, Just whenever you destroy the instance, you need to say photon model destroy model. And now, if we look in here, oh, I need to set model equals. Yeah, because we have to have a reference to the actual model. Now, if we go into the room, the cube should be gone, just like that. Pretty easy. So just always remember that whenever you're creating a model, you're creating it in the system. You're not creating it for just this object, right? Now, one of the coolest features, this is one of my favorite parts, is we can actually create static buffers and just add our models to these static buffers in any rotation, any position, etc. Right? So let's just say, all right, we'll repeat 100 times, and we'll say, actually, before we actually create the models, so there's I've got a bunch of buffer or static buffer functions in here, right? If we go into the Photon toolkit, we've got Photon buffer create, Photon buffer get, Photon buffer set. So, let me go back to my cube. So we need to create a new buffer. So we can say Photon buffer create, and we're going to call it cube buffer. And we're not going to set a shader yet, but that's coming next. That's one of my favorite parts. But you just create a buffer real quick. This will create a new static buffer. You can create as many of these as you want and put whatever models you want in them, right? Static buffers are really good because they basically don't change, so it's just really efficient, right? So great for like scenery, trees, stuff like that. So now we can say repeat 100. And we'll say var xx, yy, zz, angle, and scale. Skill. We'll say xx random room width, yy random room height, zz random 100, angle random 360, and then scale is random range. We'll say 0.5 to 1.5. Now, currently, the static buffers do not support X and Y rotations. It's mainly due to the fact that I don't really think it's that necessary with sprite stacking in particular, because once you rotate a sprite stack, you can see between the layers there, and that's usually not a thing people want. It is suggested, if you really want some rotated models like that, I would just suggest adding actual 3D models personally, mixing the two. Anyway, but so yeah, we've created a bunch of random. This will just create a bunch of random parameters for blocks. So all we need to do is say photon model set model xx yy zz 0x rotation 0y rotation. For the Z rotation, we'll click angle, and then we'll say scale, scale, scale. Then all we need to do is say photon model add static, say model, and then cube buffer, because that's the buffer we want to add to. Now that we've created a bunch of these, we don't really need our initial model anymore, right? So we can just say photon model destroy model, since we don't need, unless you want this one in particular to move around, the first model that's attached to this object right here or whatever. But we don't really need that. So we got that set up. Now let's just run the game, and it'll take a second to load. It shouldn't take very long, but boom, pretty quick load times. And look, it's still running, around 2,000 FPS, and you've got like all these cubes, random rotations, random scales, all that, random Z heights, and it's all static, which is pretty awesome. The lower you have the scale, you can see, let me get right here, this little block right here, because if you scale too far down, it's going to clip some of those sub images, some of those sprite stacks there. So I wouldn't suggest scaling down too much with the static buffers anyway. I've tried to make it to where it's pretty optimized, but yeah, I just wouldn't suggest scaling down too much. If anything, you would want to scale up more than scale down. But yeah, super easy to create. But one of my favorite things is being able to set custom shaders for buffers, for your custom buffers. So let's just create a shader real quick. This is kind of like how you would do a swaying grass shader. But we're just gonna create a wiggle shader basically. So shade wiggle. In between these two, we're gonna say vec4 op is equal to object space position. Then we can say op.x is plus. Oh, we need to. Before we get into that, we need to add a uniform. Say uniform that float time. So we'll input that in here in a second. So we'll say op.x is plus equal to time plus op.x times op.z divided or times 0.1. Let's just do that. And then we'll say the same thing for the y. op.y is plus equal to time plus op.y times op.z times 0.1. And then we'll just say object space position is equal to op. Cool. We got a simple little shader that's going to wiggle some stuff around. But how do we set that to the buffer? Well, it's pretty easy. Up here, you've got, it's not showing it right now, but you've got an optional variable to set a shader. So we got our cube buffer, and then we've set a new shader. By default, it will automatically set buffers with the default shader, which doesn't really do much. It's just a pass-through shader. But yeah, so we can set a custom shader. Then all you need to do is you have to go into this Photon uniform control, and here is where you control the different uniforms in your shader. So we would just say case shade wiggle. So this will automatically loop through all of our buffers, and it'll check for the shader that we have, and it'll run this code, right? So yeah, I've got some important, don't rename the script or anything like that, but if you do, there's how you find where it's at. So we just need to get the uniform, so we'll say var uni is equal to shader get uniform shade wiggle time. Then we just need to say shader set uniform f. Oh, sorry. I was like, I know I spelled that right. Uniform f be uni, and then we'll say current time divided by 250. All right, cool. So pretty simple and easy. Now let's run it and see what happens. Uh-oh. Well, it's doing something, but I messed up my math somewhere. Let me look in here real quick. See. Let me see what I did wrong. Oh, I'm an idiot. Cosine. Add cosine and sine to this because we want it to like actually wiggle around. Sorry. Boom. There we go. That's what I'm talking about. Now you can see we got some wiggle action going on. Yeah, there we go. So yeah, super easy just to set up a static buffer and add custom shaders to it. I tried to make it really crazy easy. It's great for like grass or anything, any kind of scenery environments. You could use it for like water if you wanted to set up, and add some water effects or whatever effects you want to do really. So that's how you set up static buffers, and that's how you can add shaders to them. It's super simple and easy. So I think that covers about the basics of it. Like I said, you can draw custom if you don't want the engine to draw it automatically for you. You can use the Photon model draw override, and it will just it won't make the engine draw it, but you can draw it yourself from the object itself. So if you wanted to set like a custom shader for a model, you might want to use this instead of having the engine render it. Photon model destroy, draw enable. This is good for if you anything that's kind of outside the view. This is just for if you want to optimize it even more. You have a bunch of non-static models, dynamic models. If they're like 500 pixels away from the camera, then you might want to turn the drawing off, and that'll save you some performance there. And yeah, so that's pretty much the basics. It's a more stripped down version, but hopefully it's a lot easier to use for you guys, and hopefully it's really easy to set up. But yeah, I think, all right, last thing I did want to cover is this. So, all right, let me make the before we get into this, let me make the camera smaller real quick so we can see how some of this is working. So I'm going to set this to 640 by 360. This essentially works the way that GM's default camera works, so it shouldn't be that foreign. Just setting the view size there. All right, yeah, we're a little zoomed in now. It looks pretty pixelated by default. I think it's the resolution is equal to the camera's width and height, and then the fidelity is just set to either 1 or 2, I believe. I think it's set to 1. But yeah, you can see it's more pixelated that way. But what you can do is on this Photon start, you can go ahead and set the resolution and the fidelity. Now, the fidelity is basically how many sprite stacks, how many little planes are in between each of the planes, right? So let's just set our resolution to 4, and we'll just set the fidelity to 1 for now. So you can see, hopefully you'll be able to see what I'm talking about. All right, if you look in there, if you kind of look towards like the edges here of these blocks, you can see there's kind of like, see those little lines there? See how that's like the edges are a bunch of little lines? That's because it's essentially you're just drawing a bunch of little planes, right? So if we want to fix that, we could say 4 and 4, right? We'll set the resolution high and we'll set the fidelity high. And this, it almost looks like just regular old blocks now. You can't even tell that they're sprite stacked. I mean, you could tell a little bit. So you might want to set the fidelity a little bit higher. But yeah, it's pretty easy to set different resolutions if you want a higher res version of the game that doesn't look quite as sprite stacked, you know, and pixelated. You have that option, and it's just right there, super easy, super simple to do. So I believe that pretty much covers it. There's not too much more to it. Like I said, I really wanted to make it insanely easy to use and set up. And like for a game that I've been working on, if you go to my Twitter at GameDev or at GameDevGizmo, I think. Yeah, for Twitter it's GameDev_Gizmo. If you go there, you can see a game I've been recently working on that I'm using this exact system for. And it's really fun. And yeah, you can't even tell that it's actually sprite stack. It looks like, you know, real 3D. So you've got that option, but if you like the pixelated look, go for it, you know. So yeah, hopefully that's a good little overview for you guys. And I hope you guys enjoy it. And let me know if you have any questions down in the comments below. I'll try to cover anything. This is just mainly a rendering engine. This is not a full 3D engine. So there's no collisions anymore. There's no post-processing effects or anything like that. I decided to axe all that for this. This is just purely for the basics, right? I left the rest of that up to you guys. But I might do some tutorials on how you can integrate like the Snyder's Cull Mesh and SMF systems with this, because it's essentially using a lot of the same techniques that because you're using vertex buffers and regular buffers to create models and everything, so you can incorporate some of that into the engine as well with relative ease, I believe. I haven't had the time to try it yet, but I do want to try and incorporate like Cull Mesh, so that way you guys can use this system and actually have full-on 3D collisions, you know, and make a full-on 3D, you know, platformer if you want a third-person platformer. So with sprite stacking instead of actual models. So anyway, yeah, I guess that basically covers it. Yeah, again, let me know what you guys think. Follow me on Twitter at GameDevGizmo. And my itch.io page, I'll have links and stuff in the description to get this completely free, and it'll come with this example that we just set up here. So anyway, hope you guys enjoy, and until next time, peace.